we want to look at another application with our triangles. And we've looked at navigation. And what we now want to look at are vectors. Now, a vector needs two things. To have a vector, you need direction. Which way something is headed. It's due north, due south, to the left, to the right. You need direction, up, down. And the second thing you need is magnitude. Excuse me. You need both of those to have a vector. So let's look at some examples. A car is traveling due north at 30 miles an hour. Its direction is due north. Its magnitude is 30 miles per hour, how fast it's going. A rocket is going up, its direction, at 150 knots. Its magnitude, how fast it's going. An apple is being pulled down, its direction, with 1 Newton of force. That's a measurement of force, how hard you're pulling. So it can be a speed, it can be a force. To have a vector, you need direction and magnitude. Now, one of the things with how do we draw a vector is we show that direction. So if I have a car going north, and let's even use this, a car going north at 30 miles an hour, I can draw it with that arrow. And the length of that vector would be its magnitude. So this would say 30. Now, if I had that vector, notice one of the things it does not say is where is it located. I could go 30 miles north in Smithville, or 30 miles north in Orrville, or 30 miles north in Worcester. Anywhere I move that vector, it is still the same vector. So, that's how we draw a vector. We have a direction it's going, and we have some magnitude. Okay? And we could say, going back to our idea of navigation, let's say this is west, 40 degrees south. That would be my direction. Okay? So now we add two vectors. Let's say two things are acting on something at the same time. Two people are pulling on an object. Or a wind is blowing and there's a current of a boat. It's trying to go across a river where there's a current and there's a wind blowing. How do we add those two forces? Well, if we have two vectors, in this case we have vector u that's going in this direction with this length, and vector v going in this direction. Now, first off, if we want to find 3u, that's going to be a vector going in the same direction as u, but 3 times as long. So it would be one vector like that. That would be 3u, because it's 3 vectors that length. If I had negative 2v, well, it's 2 v's going in the same direction, but because it's negative, its vector would actually be going in the opposite direction. And now, I don't know if you can see those on your notes, but this vector, there's an arrow here, so it's going that way. This vector, there's an arrow here, so it's going that way. So the negative changes direction. So that's how we can write vectors. Now, let's talk about how we can add vectors. So if I have two vectors that are acting on this object, and vector u is pushing it straight up, vector v is pushing it to the right, you can see vector v is much longer. You can probably guess that this object, if both of these are, let's say they're ropes that they're pulling on this object, it's going to go somewhere in the diagonal direction, right? Well, the way we can do this is, or find this, is by what's called the parallelogram rule. We take my vector, both of them acting on the same point, we take my vector u and I draw it again at the other end. I take my vector v and I draw it again at the other end. In this case, I get a rectangle, but if it was a diagonal or some other angle, it could be a parallelogram. And then I start at the beginning spot, and I go across at that diagonal, and there is my resulting vector going this way. See triangles, see our law signs, law cosines coming in here soon. Okay. So, let's say here's our vectors v and u, and we want to add them. Okay. And let's just kind of roughly draw it here. If we're at this dot right here, here's our vector u, here is our vector v. But to draw the resultant vector, I'm going to say if I add u, I redraw u here, redraw v here, and then my resultant vector is a diagonal. Right there. Let's do another one. I'm going to add v, and I'm going to subtract 2u. So u goes this way. I want 2 of them in the opposite way. This is minus 2u. I redraw those up here. I add v. So my resultant vector from the dot goes right there. This is v minus 2u. So we always want to draw this parallelogram. Now, our first kind of lab that we want to work with is, let's do these again. Let's try to do these. U and V. So we add these. U would go here. V would go there. Oops, sorry. Let me redraw those. They're both working on a dot. We always want to draw them from a dot. U goes that way. V goes that way. So I redraw V up here, draw U to get my parallelogram. Diagonal is my result. It's my dot. Here is U. Now 2V. I don't have enough room there. Let me move those over a little bit. Here's my dot. There's U. 2V. I redraw it. Now you can see it really helps if I have a straight edge. So when we draw these, we want to try to measure them and draw them. Okay. Now, we do more accurate. Let me just say here, if you have 3, all you do is you add all 3. So I would say I would take W plus U, and I would do that. Here's my W, here's my U. So my resultant vector is right there. Then I take that red vector and I add it to V. My drawing's not very good, but I get my result. So you do it in multiple steps, okay? So you can see how hard this is with my drawings to draw without a straight edge. So let's do this kind of with a straight edge. So here's our 2 vectors, and we know the angle in between. So we want to try to measure them. So how would you do this? You're going to get a straight edge and a protractor. So I notice this angle is 70. So I come down here, and from here it's 70. So right there is my 70. I don't know if that's about the same side. Let's see, is that about the same length? Oh, pretty good. Now I draw my other line on the other side. And finally, I draw my result. Now, for today, what I want you to do then is to use your protractor and measure. What's my angle here? My angle is, let's say, 26. So this angle here is 26 degrees. And if I wanted to measure that from, let's say, a due north or something like that, I could bring this over here, 90 degrees, move it over right there, and that looks to be about 3 degrees, 4 degrees above due east. So my direction is east, 4 degrees north. That's the direction of that vector. Next, see how long it is. So we're going to use a ruler. Let's get this scaled right. So this was 3. So there you can see that side measures 3. Five. So let's measure this side. There is 6.75. So my length is 6.75. So I was able to find my direction and my magnitude by graphing it and using my arrows. So that's the first thing. We just want to work on drawing and trying to draw these very, very, very accurately and measuring our vectors. So that's our first lab worksheet.